Welcome back. Problem 1.19. So statement is the load P applied to a steel rod is distributed to a timber support by an annular washer. The diameter of rod is 22 millimeter and the inner diameter of washer is 25 millimeter, which is slightly larger than the diameter of hole. Determine the smallest allowable outer diameter D of the washer, knowing that axial normal stress in steel rod is 35 megapascal and that bearing average bearing stress between washer and timber must not exceed 5 megapascal. So you can see this is the steel rod where P load is applied, and this is the timber. So in between this rod and timber, there is a annular washer whose outer diameter is D and inner diameter is DI, which is given as 25 millimeter. The diameter of this rod is 22 millimeter. So you have to find the outer diameter D of the rod. So P load is applied, diameter of rod is 22 millimeter, inner diameter of washer is 25 millimeter, axial normal stress is 35 megapascal in steel rod, while average bearing stress between the rod and between the washer and timber is 5 megapascal. So you have to find the outer diameter D of the washer. So let's start with the solution. Now you can see we will first find this P force, because we know that bearing stress, which is bearing stress is equal to load per unit bearing area. So first we will find this bearing stress, how this load P. So what we will do is that we will find we have been given the normal stress in the steel rod, which is given as sigma, and that sigma is equal to P divided by A. So we have to find this P. So P will be equal to sigma into A. Now this sigma is normal stress is given as 35 psi megapascal. So we'll find the area of this rod is equal to pi by 4 d square, and diameter is given as 22 millimeter. So 22 in term of meter is 0.022, because we know that area is pi by 4 d square. Clear? So from here you will get the area, and this area comes out to be 380 in 0.13 into 10 raised to power minus 6 square meter. Now you have this area, so P will be equal to stress into area. So stress is also given as 35 megapascal. So 35 into 10 raised to power 6 multiplied by the area, which is 380 into 10 raised to power minus 6. So when you multiply it, you will get this load P, which is equal to 13.305 into 10 raised to power 3 Newton, or you can say 13.31 kilo Newton. Now you have this P force. So definitely we have been given that bearing stress between the washer and wood timber is 5 megapascal. So 5 megapascal. We know that bearing stress is equal to force per unit bearing area. So we are interested to find out this bearing area. So AB is equal to P divided by bearing stress. So P we have calculated as 13.305 into 10 raised to power 3 divided by bearing area is 5 megapascal. So 5 into 10 raised to power 6. This will give you the bearing area. So bearing area is equal to 2.6609 into 10 raised to power minus 3 square meter. Now you have this bearing area. Now you have bearing area, and for washer you know that bearing area will be equal to pi by 4 into d square, which is the outer dia, minus di square. So if I draw the washer, it will be like this one. So this will be d, roughly this will be d, and this will be di. this will be di. So bearing area will be this one. Now we are interested to find out d square. So 4 into bearing area divide by pi, 4 into bearing divided by pi plus di square will be equal to d square. Clear? And you can just put the value d square is equal to 4 multiplied by 2.6609 into 10 to the power minus 3 divided by pi plus di square. So di is given as 25 millimeter, which is 0.025 whole square. So when you solve this, you will get d square will be equal to 4.013 into 10 to the power minus 3 square meter. And if you take the square root on both sides, so you will get 4.013 into 10 to the power minus 3, and you will get d will be equal to 63.3 into 10 to the power minus 3 meter. Or you can say in term of millimeter, d will be equal to 63.3 millimeter. So this is the outer diameter of the washer. And that was all about this problem 1.19. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.